So given some parametric equations, we want to be able to sketch the curve, including showing its orientation. And we also want to be able to eliminate the parameters. So let's first of all sketch the curve. And I'm going to do that by simply plugging in values that are in the domain of t. And often it is restricted like it is here. So we'll want to take note of that. And then we're going to go plot these on an XY graph. So t ranges from -2 to 2, so let's just pick all those integer values between there and see if that's enough to see what the curve is doing. So if we put in -2, we get -8 for the x, and we get 0 for the y. So 1, 2, 3, 4, 5, 6, 7, 8. We'll plot that right there. And then if we put in -1, we get -1 for the x and 1 for the y, so -1 and 1 right there. And if we put in 0, we get 0 for x and 2 for y, so we'll put that one right there. And if we put in a 1, we get 1 for x and 3 for y. 1, 1, 2, 3. And finally, putting in a 2, we get 8 for x and 4 for y. 4, 5, 6, 7, 8, and up 4. So this curve goes along like this, and our orientation, as t increases, we move along there to the right. Now let's go ahead and eliminate the parameter. So you pick one of the equations and often solve it for the parameter. So I'm going to solve the second equation for t. That would be y minus 2, and then I'm going to take the y minus 2 and I'm going to plug it in for t in the first equation. So x is going to be y minus 2 cubed. And that is what we're seeing, and if you don't quite see it, we could always take the cube root of both sides, and then I would also, once I get rid of the cube root, I'm going to move the 2 over. So this tells me it would be a cube root graph shifted up 2, and that's exactly what I'm seeing, but we would only have a piece of that graph because of our restriction on our parameter.